All right, so our focus today is going to be on the nature of science and the scientific method. So, first, we're going to start off with biology and what is biology. So, first, we're just going to dissect this word here a little bit. Biology. Bio means life, ology means study of. So essentially, biology is the study of life. So in this class, we're going to be talking a lot about all things living in the world, what they do, how they survive, the study of life, all things living. But before we can talk about biology and living things in particular, first we have to talk a little bit about science. Science itself, the way that we learn science, the way that scientists in the real world do science. So, science itself is a way of knowing. So, it's a way that scientists get to know the world around them. And I ask a lot of students in class, are you a scientist? Have you ever been a scientist? And their first answer is no. Well, I'm here to tell you today that that's incorrect. Everyone is a scientist because everyone tries to do things to get to know the world around them, and you do it on a daily basis. I remember it's been years now. My niece was small, and we were cooking. She liked ramen, so we were cooking ramen, and I said something about I don't want to put my hand over the steam because it's hot. And she was like, "No, it's not. It's just water. It's not hot." And I remember we went through the process of helping her figure out just by like putting her hand way over the boiling water, like way above the pot, and slowly lowering it down, and she could feel the heat. And that's how she got to know that, oh, when you boil water, it's hot. I mean, while that sounds silly, like to us, I'm sure that sounds really silly, but you do it every day when you walk outside and you're like, ooh, what is that weird little bug? Or why is, I don't know, this blowing in this direction? It happens every day. And one of the ways that we figure out the world around us is by doing a process called inquiry. And essentially, the process of inquiry is searching for information and explanations by asking specific questions. And again, you do that a lot. Sometimes you see something and you just ask question after question after question, like little kids. We still do that in our heads. We see something and we might not like want to vocalize all the questions that we have, especially if they're weird ones, but we always are asking and trying to solve questions. And the way that we go about doing that is by making observations of the world around us. And while you may not have heard of the word observation, again, you do this all the time. So, observations are using our senses to gather information. And our senses, you can either see it, a lot of our senses are seeing, you can hear it, you can smell it, you can touch it, and oftentimes it's frowned upon in science, but it happens. You can taste it. And we record these, and they come in all different types of data. And they can either be one of two things. They can either be qualitative, and qualitative is about the quality or description of something. It can be color, it could be texture, it could be whether something is wet or dry, it could be something you hear, you could say something tastes salty. Those are qualitative observations. However, sometimes our observations are going to include a number, and those are called quantitative. And quantitative has this N, and that N is going to stand for number. So anything that has a number in it. I see 2 birds. The bird has 7 spots. Anything with a number, or maybe the fence is 5 foot high. Those require or have numbers and measurements, so they are quantitative. Anything that does not have a number is going to be qualitative. And typically very shortly after you make your observation, and sometimes you lump these into one step, you are then going to, more likely than not, make an inference. So you make your observation, which is again what you sense around you. You see it, you hear it, you touch it, you smell it, you taste it. You do one of these. And then pretty closely afterwards, you're probably going to make an inference. And sometimes you might even notice yourself skipping right to the inference step. I know that I do sometimes, when you don't even really notice the observations you make. So an example would be walking my dog around the block. When I walk my dog around the block, the neighbor, a couple houses up, has a dog in a fenced-in yard, and every time we walk by, it comes up and it barks and barks and barks, really like deep barking, and when it barks, it shows all its teeth. And so I think it's a really like mean dog. I'd be really afraid of it if it got out of the fence area. So me saying that that's a mean dog, that's my inference. I infer that it's a mean dog. I'm guessing it's a mean dog. I really don't even know that dog. But my observations lead me to believe that it's a mean dog. My observations being it barks really deep, sometimes it growls, and it shows its teeth at me. That is me inferring it's a mean dog through my observations. And then after we have these questions, we make our inferences, we're going to want to try to figure something out. So if we have, let's say we're studying fossils and we see this set of footsteps here. I see two sets of footsteps coming in. That's a quantitative observation. One is green, one is red. Qualitative observation. In the middle here, this is where you're going to start having your inferences. I infer they are fighting. I infer they're dancing. Maybe they are, I don't know, horse playing. Who knows? Dancing, fighting. Those are typically the ones I hear. And then, again, more inferences. One died. One ate the other. One gave one a piggyback ride. Those are my inferences. My observations would be two sets of footsteps came in. One was green, one was red. They got all jumbled up. And the green set of footprints left. And that was the only set of footprints that left. You don't know what happened. You infer that they were fighting. You infer that one died. You infer that the red one got up and flew away. You don't know. And you're going to have some type of testing to figure out for sure what exactly happened there. And that leads us into hypothesis-based science, which is the process of you making a guess about what happens or what's going to happen, and then testing that hypothesis or testing that guess. So a hypothesis is an educated guess based on an experience that you've had, the information that you already know, any data that you have there. So your hypothesis is going to be something that you think, based on what you know, could potentially be true. And when you're making your hypothesis, it has to fall into these three categories. You have to be able to check all of these boxes for it to be a good hypothesis. The first thing is you have to be able to test it. It has to be something that you can actually test. It also has to be falsifiable, and what that means, falsifiable means it can be proven wrong. So it has to be able to be proven wrong, and then it's never proven beyond a shadow of a doubt. In science, things aren't 100% certain. Things are never always true. They can be proven wrong. Someone does another experiment, shows you were wrong. Now we have to change our way of thinking, and this happens a lot of times in science. So for your hypothesis to be a good quality hypothesis, you have to be able to test it. You need to be able to be proven wrong, and it can never be proven beyond a shadow of a doubt. So it can be proven wrong. And then we go into testing. And this whole process is going to be called the scientific method. Now, I'm going to note that the scientific method here that we have, it's broken down into 5 steps. I do want to say this is the basic scientific method. These are the basic components. In the real world, sometimes you get to step 3 and you got to go back, where you get to step 4 and you need to go back and you have to make changes. So this is a fluid process. It's not always 1, 2, 3, 4, 5. Sometimes things get mixed up. Sometimes you have to go back and adjust, and that's okay. But in general, the very first thing that you do is you collect an observation. So you notice something about the world around you, and then you're going to ask a question. So I might see something happen. I ask a question. What did I do? A couple years ago, I was planting tomato plants. I wanted to grow my own tomatoes to make my own garden. And I had been growing them inside, and I kept them under the light. And they're about 3 or 4 inches tall. And one day I set them outside. I was like, oh, it's going to be really good for them to be outside. And I left them outside for several hours. And when I went back out, they were white and they were dying. That would be my observation. My observation would be I left my flowers outside in the sun for 4 hours and they turned white. Why did this happen? That would be my question. My next step would be forming my hypothesis, so my guess. And my guess was I exposed them to the light too fast, so the sun burnt them. And then I'm also going to make a prediction. Your prediction is going to be, if I'm right, what is that going to look like? So if the sun burnt my plants, then they're going to turn white. Or if I didn't leave my plants out in the bright sun and I just exposed them slowly, then they wouldn't die. That's going to be my prediction. Step 4 is going to be performing your controlled experiment. And your controlled experiment is going to have different variables and different groups and have different requirements that we're going to talk about here in a minute. So this is your actual experiment. And then you're going to draw your conclusion. One thing about the conclusion I want to say is no matter what order you do these steps in, even if you have to go back and adjust, the conclusion is always at the end. So sometimes you'll get a question on the SOL and it would be like the experiment showed that this thing happens. And if the experiment showed that something happened, it's past tense, that's going to be a conclusion. The experiment showed that my plants died because I put them out in the sun too much. That's a conclusion. So the conclusion is always going to happen at the very end. So we're going to go through this with a funny example. So we're going to make an observation. Again, your observations come from your senses. They can be qualitative or quantitative. Qualitative observation is going to be something like color, texture. Maybe you notice something happens. This one's going to be something that you notice. And then the quantitative is always going to have a number. So, for example, let's just say I notice I cannot get a date Friday night. And my question is going to be, why? This is going to be qualitative observation. Oh, I can't spell. So that's a qualitative observation that I have. And you want to be able to remember that you can't solve a problem unless you know exactly what it is. So make sure that you're specific around the question that you ask. So here, my question is, I can't get a date for Friday night. Why? My next step is going to be to make my hypothesis. So, my educated guess. This is not the case, I hope, for you guys, but let's just say my body odor is preventing me from getting a date Friday night. Could be maybe you're not dressing that fancy. I don't know. Maybe you need to spruce up your game and not wear ripped jeans. I don't know. And after your hypothesis, you're going to make a prediction. And again, your prediction is, if I'm right, what is that going to look like? So it's always written as an if-then. So my example is going to be, if I wear perfume, then maybe I'll get a date. So that's an example. It could be, if I dress more flashy, then I'll get a date. And you could do whatever it is that you would like there. And then you're going to be led into the actual experiment. And your experiment, in order to be a good quality experiment, a few things have to be true. And you're going to have different groups. The first group is going to be the control group. And the control group is going to receive no experimental treatment. So in this case, it's the group that you do nothing to. You give no cologne to. So in order to test this, let's say I'm going to choose 5 dudes. So I'm going to have 5 men. I'm going to have 2 groups, so group 1 and group 2. Each one's going to have 5 men. In group 1, they're going to have no cologne. Group 2 is going to wear cologne. Is that how you spell it? Yeah. Group 1, 5 men, no cologne. Group 2, 5 men with cologne. Since group 1 didn't receive any treatment, you did nothing to them, you just let them do their normal thing, they're the control group, and I like to say this one as receives whatever's normal. So they get the normal thing. Sometimes the normal thing is going to be doing nothing to them. Sometimes you're going to have to give them something. So if I'm testing different colors of light on plants, normal color light, so just normal white light, is going to be the normal thing. Whereas different colors are the weird thing. So I'm giving them the normal thing here for the control group. My group 2 is going to be 5 men wearing cologne. This is my experimental group. I'm testing to see if cologne works. So this is my experimental group. And this group is going to get the new thing that I am testing. So if I'm testing cologne, they get whatever's new. Maybe my new type of cologne is going to be the new thing. They get the new thing. And they're called experimental group because I'm experimenting to see if the cologne works. I could be wrong. Cologne might not be the thing that's going on here in this situation. However, it's the thing that I'm experimenting with. I'm trying to see if the cologne actually works. So that's my new thing. And I also want to note, this is very important here, everything about these groups should be identical except for the one thing. So you can only change one thing. Well, let me write there. There we go. Can only change one thing. So for these groups, let's say I'm going to have 5 men wearing no cologne and they're going to wear jeans. I have to have, if I've already changed cologne and no cologne, they have to wear the same thing. Because if these guys are wearing jeans, these guys are wearing tuxes, I don't know if they're getting dates based on what they're wearing or what they're smelling like. So I can only change the one thing. So I know why they're actually getting dates. I know the reason that these different things are happening. So we got to be very clear about that. You can only ever change one thing, and that's going to be the one thing that you're testing. So when you're doing your experiment, all experiments have to have a control. If they don't have a control, it's not a good experiment. It's not going to be trusted. Scientists are not going to agree with your opinion if it doesn't have a good control. It has to be repeatable, meaning if I give all my steps that I take to someone else, they have to be able to do it again. Because the way science works is if I go out in my backyard and I do this cool experiment and I come tell you about it and I'm like, dude, you're not going to believe the awesome thing that I found out. And I tell you something crazy like, under the ground there are these giant bugs, and they only come out at nighttime or something like that. If I told you I did this experiment in my backyard and I found that out, you're not going to believe me. You're not going to believe me. The only way you'd believe me is if you could go out in your backyard and figure out the same thing. So it has to be repeatable. And it also has to avoid bias. Now, not all problems are going to fall into this boat, but it does have to be biased, meaning your personal opinion cannot sway the experiment. You have to just lie strictly with the facts, what happens and what doesn't. And then there are the things are called the variables in the experiment. And your experiment is going to have two different variables. The first is the independent variable. And this is going to be the variable that you change. So I and independent equals I change. I change the independent variable. I change whether the guys are wearing cologne or not. I change that. Versus the dependent variable. The dependent variable is going to be the thing that changes based on the independent variable. So it depends on the independent variable. IV for independent variable. And the dependent variable is always the thing that you measure. So I change whether the guys are wearing cologne. I measure whether or not they get dates. And it's always going to be quantitative. So in my date example, I'm seeing how many dates they get. How many out of my 5 dudes get a date? That's going to have a number. So it's something that's going to be measured. Dependent variable is the thing that's measured in the end. So if I give you an experiment and I say we're testing to see whether listening to music helps students do better on tests, then the independent variable is whether or not they listen to music. Dependent variable is going to be the grade they get on the test. And then the last step in the scientific method is going to be coming to drawing the conclusion. So I did my experiment, I collected my data, and now it comes to the part where I have to say if my hypothesis was right or wrong. So it could be supported because I was right, or it could be rejected because I was wrong. So you have two different things that can happen here. Conclusion 1, if you're right, you're supported. That means you got a date. Your people had dates. Number 2, if you were wrong, your hypothesis is rejected and you're going to be lonely on Friday because you didn't get a date. That means it wasn't the smell, it must be something else. And that would be maybe you're going to go back and do something. Maybe you're going to run a different experiment to figure out if it's something different. Maybe this time you're going to look at your outfit or your hair or I don't know, the way that, I don't know, maybe you're mean. Maybe you need to adjust that. I don't know. You're going to look and see, figure out if there's something else you need to change. And this is what's going to lead to theories and laws. So after lots of experimentation, something can either become a theory or a law. Theories, a theory is going to be something that's been experimented multiple times. So many people did an experiment and everybody got the same result. And it seems that that idea is true. So it's been tested many times and seems to be true. Now, that means seems to be true. It can still be proven wrong. So you could have a theory that people believe for years and years and years and years. New scientific study comes out and it's proven wrong. Then we have to adjust that theory. So again, future evidence can change it. It's been tested many times and seems to be true. That is a theory. A lot of things are just theories in science, like the theory of evolution. We believe evolution to be true because we have lots of different tests that make it seem like it's true, but we don't know for sure because scientists is never sure, it's never certain, it's never proven beyond a shadow of a doubt. Versus laws. So, laws summarize a different group of observations, and we just generalize what we think is going to happen. And laws are going to describe something, they don't explain why it happens. So theories up here, they explain, they state why something happens. It requires lots of data, lots of experimentation, whereas laws just describe it, and they often come with mathematical equations. So a good one would be like Newton's laws. So those are going to be laws. Newton's laws would be like, if you throw something up in the air, it's going to come down. So whatever goes up must come down. That is a law. It only describes what happens. It doesn't say why that happens. So laws describe what you observe. They don't explain it. So, and oftentimes they have a mathematical equation attached to them. We're not really going to talk about too many laws in this class, but you'll see them in later sciences. Okay, so the next thing we're going to have is going to be some practice.